all know that we live in a third-dimensional world. Have you ever wondered if there is a fourth dimension and what can it be like? Well, in physics, the fourth dimension is time. My name is Wissal Barti, and in this video, I'll be explaining how the interaction between time and space can bend the light. In 1905, the German physicist Albert Einstein brought up a new concept in his theory of general relativity about gravity, defined by Isaac Newton in 1684 as the force that attracts two massive objects towards each other, and the more important are their masses, the biggest the attraction. Whereas Einstein claimed that gravity is nothing but cause reaction in space-time. Talking about reactions, we as humans react to news by smiling, crying, getting angry, or anticipating it. This is our language of communication, and so do stars, planets, and black holes have their own language of communication, which turns out to be the attraction of any object that comes near them in the fourth-dimensional continuum.
Let's take for example this bowl of honey. As we can see, it represents space-time. The ball on the right is just a random star, the one in the middle is the sun, and the one on the left is the earth. So we can see that their heights are different. It's because of the difference of their masses, and so it affects their capacity of attraction. Let's take this drawing as a simpler example. Here's the earth, the sun, and the star. So let's imagine that there is a radiation of light, which is an electromagnetic radiation which transits from radio waves to gamma rays, and its detection is responsible for us seeing what's around us. Look what will happen when this radiation will come near the sun. It's deviated. It changes its direction. Here's the observer on Earth. The observer will think that the real spot of the star is actually here, while he's wrong. The real spot is here. So let's imagine this time an infinite amount of radiations coming out from the same star. Each radiation will be deviated by a certain degree. So the observer will once again think that the star is here. And then the observer will think here that the real spot of the star is here, and then here, and so on, till the Einstein ring is formed, also known as the Einstein-Schwarz ring. It's actually insane and astonishing in the same time that Albert thought of photographing stars in the morning while in eclipse, and then photographing them once again at night, so that he can prove to scientists that stars don't keep their exact same spots at night and in the morning when the sun is present. So as a result, light is bent.